In this video, we want to take a look at motion. Let's have some explanations so you can put them down before we move straight to the calculation. Motion is any change in position or direction of a body or particle. We can study it under two categories. The first one is kinematics. This is when we're studying motion without the cause of the motion. Then the other one is dynamics, when we are studying motion with respect to the cause of motion. We have types of motion. We have linear motion or translational motion. That's when a body is moving along a straight line. Number two, we also have oscillatory motion or vibrational motion. That's when a body is moving to and fro about a fixed point in its path. Another one is Brownian or random motion. So random motion or Brownian motion, that's a haphazard motion or a scattered motion of a body. We also have rotational motion, which is the movement of a body about its central axis. We also have circular motion, or what we call revolutionary motion, which is the movement of a body round about a central axis or round about a central fixed point. There are some terminologies that we consider in motion, which is distance, production of length in a specified direction. We have displacement, we have speed, we have velocity, we have acceleration. So let's look at the equations of motion. There are basically four equations of motion. The first one, we have that V is equal to U plus AT. We call it the first equation. The second one, we have that S is equal to V plus U over 2 multiplied by T. That's the second one. Then the third one, we have that S is equal to UT plus half AT squared. Then we have the last one that says V squared is equal to U squared plus 2AS. Now here, A stands for acceleration, T stands for time, S stands for distance, U stands for initial velocity, and V stands for final velocity. So let's now look at the rules for linear motion. We have the number one rule that whenever a body starts from rest, it means that initial velocity is 0. The second rule is that whenever a body comes to rest, the final velocity V is 0. Then the third rule is that when a body is moving with constant speed or velocity, then it means that the acceleration is 0. We also need to note that the opposite of acceleration is called retardation. So for this video, we're only going to consider linear motion, and in another video, we're going to consider vertical motion. In another one, we can consider circular motion and the rest. So let's look at this example. A car moving with a velocity of 36 km per hour accelerates uniformly at 1.0 nanometer per second squared until it reaches a velocity of 54 km per hour. Calculate A, the time taken, B, the distance traveled during the acceleration, C, the velocity reached 100 meters from the place where the acceleration began. Okay, here, first of all, we need to convert this to meter per second, meters per second, because it's in kilometer. Then here we need to translate it, and so as this as well. Okay, so for 36 km per hour is 36 kilo means 1000, so times k, which is times 1000. Per hour means hour is down, so 60 minutes times another 60 hour, so which is 36 times 1000 over 3600. So this takes this away, this takes this away, 36 takes away 36. What is left for the initial velocity is 10 meters per second. So, our u is 10 meters per second, and our v is um, 54 kilometers per second. If we translate that, we're going to get 15 meters per second. And then our A is 1.0 nano, which is 1 times, nano means times 10 raised to power minus 9 meters per second squared. So having done that, we can now solve for the A, time taken. We have an equation that says that V is equal to U plus AT. So V is equal to U plus AT. Why are we using it? We have U, we have V, we have A. So U, V, A. We have them. Then we're looking for T. So all we need to do is to make T subject of the formula. So if we make T subject of the formula, T becomes V minus U all over A. If we plug in the values that are there, we have 15 minus 10 over 1 times 10 raised to power minus 9. And if we evaluate that, we're going to get 5 times 10 raised to power 9 seconds. So the second one wants us to calculate the distance traveled during the acceleration. The distance, we already have this one where we have V, U, and T already. So all we need to do is we plug it in. Distance is equal to V plus U over 2 times T. If we plug in the value, we have our V is 15 plus 10 over 2 times our T is 5 times 10 raised to power 9. So if we press that in the calculator, we'll have 6.25 times 10 raised to power 10 meters. So we need to turn over for the third one, C. So C says the velocity reached 100 meters. So the distance we're going to make use of is not this one. So the distance we're going to make use of is this 100 meters given to us from the place where this acceleration is. So we're going to make use of this acceleration. So from that question, our distance is 100 meters. And then we don't know the velocity, the final velocity, but the u given to us still remains this. And then our a still continues to be 1 times 10 raised to power minus 9, yes, then meters per second squared. So we have an equation. We have S, U, A, and V. That's the parameters involved. Now, if we go through the equations of motion, we'll notice that V, U, A, and S. V, U, A, and S. So that equation suits it. So we're going to use the equation that says that V squared is equal to U squared plus 2AS. So V squared, we don't know U, 10 squared plus 2 times A. Our A is 1 times 10 raised to power minus 9 times the distance we're going to make use of is 100 meters. So if we get this 100 and then we multiply out all through, we're going to get so the final days we'll get using a calculator, we'll get 100. So V squared is 100, but what we're interested in is V alone. So V is square root of 100, which is 10 meters per second. And that is really correct, because if you check, we are to calculate where the acceleration actually began. And that acceleration actually began at the place where initial velocity was 10 meters per second here, which is we resolved to be 10 meters per second. So that place it began, that's the final velocity. For example, a particle moving in one dimension with constant acceleration takes a time 5.0 seconds to cover a distance of 100 meters between 2 points in its path. Its speed as it passes the second point is 40 meters per second. Calculate A, the acceleration, and B, the speed of the particle as it passes the first point. Now let's bring out the parameters given to us first of all. We have time as 5 seconds, and then we have distance as 100 meters. Then we have velocity passes the second point, which is v, as 40 meters per second. Now we're looking for a, and we're also looking the speed as a initial speed that is using to pass the first point. So what we need to do to, first of all, for us to find a, we need to first of all find u. So we need to find the second one first, the u. When we get the u, we can now use it to find the acceleration, because a acceleration is equal to v minus u over t. So we don't know what u is. So let's first of all find the first one, because the first one, the b part, we can use s is equal to v plus u over 2 times t, because we already have these things here. So 100 is equal to 40 plus u over 2 times t, which is 5. So if we calculate this, we can have cross multiply 2 times 100 is equal to, we can have 40 plus u times 5u, because this 5 is multiplying the people inside the bracket. All right, so if we have this, okay, let's just break it down one step at a time. This goes here. First of all, 40u times 5. Let's take it so that the next one we can now bring it. So 40u times 5. So what we'll now have is 200 is equal to 5 times 40 is going to give us 200, right? Yeah, 200. 5 times 40 is 200. 5 times u plus 5u. Yes, so we can make 5u subject of the formula, which means this crosses over. We have that 5u is equal to 200 minus 200. So 5u is equal to 0. Therefore, u is equal to 0 over 5, which is 0 meters per second. So if u is 0 meters per second, we can now plug it in to find acceleration. Remember the formula here. So for us to find the acceleration, we can, let's just fix it here. We can see that a is equal to v minus u over t. So if we fix the value, v is 40 minus u is now 0 that we calculated over t is 5. So if we do that, 40 divided by 5 is going to give us 8. So a is equal to 8 meters per second squared. So this is the a part, this is the b part. So we solved the b part first. And then we solve the a part. So subscribe to my channel, share the video. Thank you.